Guys, thank you so much for joining me today. All right, this is Oluwaseun here. Welcome back to my channel. All right, so today we want to discuss an interesting topic that is also very important for us to know and understand as DevOps, all right, engineers. Today we're discussing the subject of virtualization. All right, that is what we're going to be looking at today. So without wasting our time, let's get right into the concept. Now, what is virtualization? Now, a virtual machine is a software-defined computer. Okay, so which means it's not a physical hardware. It is what is software defined, which means you have to install a software on a physical computer in order to be able to virtualize. Okay, so a virtual machine is what is software defined. Let's get that clear. A software defined computer. So it's not an hardware computer, it is what is software defined. So basically the RAM, the memory, all right, the CPU, the storage, everything is actually defined in form of a software, right? And this software actually runs on a physical computer. Okay, and of course, this is, it has its own separate operating system and computing resources. So, for example, you have a physical hardware, all right, and then the physical computer in this case is called the host machine. Okay, so the physical computer where you install this software that it would help you to be able to virtualize and run other operating system is referred to as the host machine. And then the virtual machine that is software defined, okay, is referred to as what? As the guest machines. Okay, so on the physical machine, you have a software installed that allows you, okay, to install other operating systems. So these other operating systems are referred to as what? As guest machines or VMs. Okay, now something is responsible, okay, for that, for that virtualization, right? The software has a name. So what is the name of the software that allows us, all right, to be able to create, all right, different VMs on our host machine? Now, the name of that software is what you call an hypervisor. Okay, so the software is called what? An hypervisor. So the hypervisor is what you install on the physical hardware that allows you to now create different virtual machines, all right, that you now want to use. So you have your physical hardware, you have the hypervisor installed on it, and then on top of the hypervisor is where you now install, all right, your virtual machine. Okay, so in this case, the hypervisor is the software defined. All right, it what allows us to create that software defined computer. So all of these VMs that you see here are actually defined in form of a software. All right, and basically what they do is that they leverage the resources of the physical hardware. Right, so if you have, let's say your physical machine is, let's say it's an Intel Core i7, for example, and it has, let's say it has about 20 processor. Okay, it has, let's say 16 gig of RAM. It has maybe a 1 terabyte of storage and all of that. Now, by the time you're creating these VMs, you're basically sharing that physical resources, okay, amongst the VMs. So VM1 can take like 4 of the processors, all right, can take about 2 of the 16 gig, okay, of the RAM with, all right, from the 1 terabyte of the storage, all right, it can take about, let's say 100 gig, all right, or 200 gig, okay. So basically the VMs will basically be sharing the host resources, all right, the physical hardware, it's going to be sharing it. Okay, so that's what a virtual, all right, machine is. So again, a virtual machine is a software-defined computer. So which means it's a software that you install on a physical computer, and then from that software you can now define, all right, the properties, all right, of your VM, the resources that your VM, all right, would leverage, okay, based on the capacity of the physical, all right, hardware. And then all of these, all right, is made possible by what you call a hypervisor. Is that okay? Now, let's try to understand what an hypervisor is. Now, an hypervisor, like you said, is a software component. And what it does is that it manages multiple virtual machines. That's what it does. Okay? So you have the hypervisor installed on your machine, and then it helps you to manage multiple virtual machines. That is just basically what an hypervisor does. Okay, now it also ensures that each virtual machine gets allocated resources and do not interfere with the operation of other virtual machines. So that means your hypervisor can also help you to isolate, all right, your VMs one from another. Okay, so what is happening on this VM, all right, is not affecting what is happening on this other VM. So apart from managing the virtual machine, it also provides a form of isolation. So if this VM has an issue and is not working, it does not mean the other VMs will not work. So basically, they are isolated. Okay, they are isolated. So that is one of the things that your hypervisor allows you, all right, to achieve. Now, there are two types of these hypervisors, okay, that we must understand. There are two types of these hypervisor that we're talking about. All right, we have the first being what you call a type 1 hypervisor, or you can call it a BM metal, all right, hypervisor. Now, the reason it is called a BM metal is because this software can actually be installed directly, all right, on a system that does not have an operating system installed, which means this hypervisor will act as the OS of that system. Okay, now, of course, I know we are used to the fact that, okay, when you have a system, the system must come with an operating system, maybe Windows, Linux, or Mac, all right, but in this case, your type 1 hypervisor can also run directly on the hardware without an operating system. Okay, so that is why it is called a type 1 hypervisor. Now, this type of hypervisor, all right, are basically used in enterprises. Okay, so if you look at this diagram, you have your hardware, you have your hypervisor installed directly, and then on top of the hypervisor, you can now start creating your virtual machines. Okay, so these type of hypervisors are used in enterprise. Okay, and one of the advantages of the type 1 hypervisor is that there is no overhead from the host OS because the hypervisor is interacting directly with the system hardware. It is not going through any operating system. Right? So basically, it manages the hardware resources directly. Okay, so there's no middleman in this case, right? So that's one of the advantages of the type 1 hypervisor. Now let's take a look at examples that we have. We have the VMware EXSI is one of the enterprise grade type 1 hypervisor, very efficient, all right, very robust. And we also have the Zen project, all right. These are the two major type 1 hypervisors, all right, that we have. Okay, now let's take a look at a second type of hypervisor, which is called the type 2. All right, hypervisor, which can also be referred to as a hosted hypervisor. Now, of course, as you must have guessed by now, the difference is that the type 2 hypervisor runs directly on an operating system. So which means you must have an operating system installed. It can be Windows, it can be a Mac, it can be Linux, all right. And then on top of the operating system, you now install, all right, the hypervisor. So if you look at the diagram here, you have the hardware, then the host operating system, and then you have the hypervisor installed on top of the host operating system, and then you can now start creating your VMs, all right, on the hypervisor. Now, the drawback of the type 2 hypervisor basically is that there's a lot of overhead because it uses the OS to assess and coordinate, all right, the underlying hardware. So unlike the type 1 that has access directly to the hardware resources, manages it directly, right, the type 2 hypervisor will have to manage these resources through the host operating system, all right? So there's a middle person, all right, in the form of the host operating system. Now, these type of hypervisors, of course, cannot be used for enterprise. They are actually suitable for end user computing. So, for example, if I want to just test something on my system, if I just need, maybe I want to test maybe a Linux operating system, all right, on my computer, okay, I don't need to go all the way to install a type 1. I can just install a type 2 hypervisor. And a common example of that is our VMware Workstation, all right, and of course, the popular one, which is the Oracle VirtualBox. Okay, so these are examples of type 2 hypervisors. So you have your operating system already running on your system, and then you can install these type 2 hypervisors on top of your operating system. Okay, and then you can now create, all right, as many VMs, all right, as you want to create. All right, now The last thing we need to look at is the hardware requirement, right? We've talked about the importance of virtualization, what it helps us to achieve, all right, and all of that. But then we need to also understand what are the requirements, because I mean, it's not every operating system and it is not every processor or hardware that can actually run, all right, a virtual machine. There are requirements that your system must have, all right, in order for you to be able to run a VM on your system successfully. Now, we're going to be looking at just three, all right, of these requirements. Number one, the CPU. Now, your system CPU must have a CPU that supports virtualization extension. All right, there are two of them. It's either it has to be Intel VT-X or AMD-V. Now, where do you check, all right, if your system has these things enabled? Now, there's what you call a BIOS, all right? When your system is booting up for the first time, you can actually press, for some system it is escape, for some system it is F2, all right? For some system it is F8, right? Now, when you press the F2, the escape, or the F8, whichever one your system is using, all right, it takes you to what is called the BIOS setup, right? The BIOS is actually where you can configure your system behavior at startup, right? What are the things you want to, disable or enable when your system is booting up for the first time? Okay, so when you go to the BIOS setup, you have to check under, there's this virtualization tab. Okay, under that, you can see whether your system support virtualization or not. So if you check that tab, depending on the processor you're using, if you're using Intel, check if the Intel VT-X, all right, is there. If it is there, you can enable it, all right, in order for you to be able to run or to host virtual machines on your system. And for AMD, just look out for AMD-V, all right, enable that, and then you are able to run, all right, your VMs. Because a lot of people want to run virtualization on their system, but they are not aware, all right, of this requirement, okay? Because if you get any any virtualization software like your Oracle VirtualBox or the VM Workstation, if you install it on your system, it's going to install, all right? But then at the point where you now want to create a VM, that's when you now start getting all these errors. Okay, so we must be aware that there are requirements, all right, before you can actually host a VM on your system. So Intel VTX, AMD-V, these are two things that you should check out for in your BIOS, all right, to check if your system supports, all right, virtualization. All right, now the second one, of course, is your RAM. Of course, you must have sufficient random access memory, all right, to be able to run a VM. Now, for example, somebody that has a system that has a 4 gig RAM and then you want to host another Windows operating system on your system, of course, there's going to be a problem because, I mean, your host operating system is already using some part of that RAM, and then you now want to host another operating system that is equally as powerful as your host operating system, then there will be a problem. So depending on the kind of operating system you want to run as VM, you must ensure that you have sufficient RAM, all right, on your system. Now, the third one that is important is storage, which is your hard disk drive. You must also ensure, because each VM that you create will actually create, all right, a disk drive where it will store, all right, its, data and every other thing, right? So you must ensure that you have enough disk space, all right, in order for your VM to create a virtual disk that will host its own data, all right, and other things that it uses, okay? So if your system is a 250 gig, all right, kind of system, right, and then you already have, maybe you use like 50 or 60% of that storage space, then you may want to think again, all right, before you go ahead and host, all right, a VM or to create one, all right, on your system. Okay, so these are the things that I believe we need to understand when it comes to virtualization. It's an important technology, which is actually one of the things that has helped us to, allowed for the cloud computing to become very popular today, right? All of the EC2 instances, the Azure VMs that we launch, all right, all of those things are actually, powered by virtualization, all right, technology. Okay, so I hope this has been informative for you. If you have any questions, okay, just put it in the comment section and I'll try my best, all right, to attend to every question that you may have. Okay, so thank you for taking your time to watch this video. All right, once again, my name is Oluwaseun, all right, and we're on a journey to becoming a DevOps, all right, engineer. So thank you, and I'll see you in the next video.